Hey there. So I happen to be going on a job interview tomorrow, and I thought I'd cover some tips and tricks for your actual job interview. The first thing that you'll be bringing, of course, is your binder of some sort. Usually you'll want it to be a nice leather one like this, something simple. You don't have to spend a lot of money on it. This one I actually only use for interviewing, so every once in a while I have to get it out. You can see there's dust on it. I gotta dust it off. But anyway, this is the binder that I use. So let's open it up. Now I already took out because I didn't want my address and such shown, but you want 3 copies of your resume and 3 copies of professional references that you have available. Okay, that's obvious stuff. Because a lot of times you'll go into an interview and there's going to be more than one person there. Not everyone is going to have a copy of your resume potentially, so it's best to show them that you're prepared by having it. Okay, so one thing that you definitely want to be doing during an interview, you want to pay attention while they're talking, but at the same time, you want to be able to take notes. Every once in a while when they say something important or something of interest to you, write it down. It shows that you're organized and that you keep track of things, because there's nothing worse than having somebody that doesn't take any notes and then later says, hey, I wasn't paying attention, what were you supposed to be doing, that sort of thing. It just doesn't give them a warm fuzzy feeling. And trust me, I've done interviews for engineers before, and these were the kinds of things that I was looking for. Okay. You definitely want to make sure that you have some kind of writing device. It would be very embarrassing if you got there and you had nothing to write with and had to ask somebody else for something. It doesn't have to be a fancy pen. You're an engineer. You're not a salesperson. You're not a CEO. You have no one to impress as far as the looks of your pen goes. So use something you're used to and comfortable with. I happen to like these big round sticks, and we have a bajillion of them. Another thing to do, test it. Make sure it works. I actually got caught in that trap once before where I went to write. I'm going to test it now. And it works. Because this just sits, on the shelf in my office. I don't use it unless I happen to be going on an interview. It had been a particularly long stint without having an interview. Had some steady work, so I didn't need to. And well, it turns out when I got to the interview, my pen didn't work. The good news is I always keep, and you'll see there's a pouch over here, I always keep extra pens in that pouch for that very purpose. The good news was another pen that I had did work. So don't get caught in that circumstance where you have that old pen dried out, doesn't work. Okay, now this is an engineering interview. This is not an interview to be, say, a cashier or a salesperson. There's a specific type of job that you need to be able to do. Now, given it's not necessarily a design engineer position, perhaps it's a product engineer or project engineer position. But engineering is just as much an art as it is a science. I think it's important to show people, have something for them to hold on to and look at. Show them examples of some of your recent work. This is some work that I had done, different circuit boards I had created. And, you can hand these around. Now, this particular job for me is a PCB design engineer position, so it's rather important that I have circuit boards to show them. But I think even if it's not a design position and you don't have anything to show them, go out, if you have enough time to do it, go out, design something. It doesn't matter what it is. It could be a little circuit that flashes an LED. Lay out the circuit board, design the circuit, write down all the calculations applicable to it. Show them that you know what you're doing. Build a BOM, a BOM. That's a bill of material. Show them that you can document these things. Draw out a schematic. Because you may only have one little piece of the pie as far as job responsibility. But the fact is, you need to understand the big picture. And if you show them that you understand the big picture by doing this, they're really going to be impressed, and they're basically going to hand the job to you. Trust me, you might feel awkward bringing things in there and showing it. They're going to be impressed by it. There's no way that, unless you did a really terrible job and it looks bad, there's no way that they're going to be dissatisfied with that or look at you strangely. Hey, maybe they will. I don't know. If you look strange, they might look at you strangely. Anyhow, over in my pocket here, I keep any business cards that might have been given to me before, so I have that information. Like I said, lots of pens and pencils, backups for writing. Make sure your pencil's sharp. And again, engineering interview. What do you want on an engineering interview? A scientific calculator. Trust me, in a lot of these engineering interviews now, they're going to give you some math problems and they're going to want you to try to solve it. And it might be as simple as, basically some algebra problems that you figure out, generic math, or, maybe it's actual electronics related questions. They might ask you, we have a low pass filter, single stage, and we want you to find the cutoff point, the minus 3 dB cutoff point with this particular resistor in this capacitor. How do you do that? Well, you may not know how. So what you need to do, go back, especially if you've been away from university for a while. Some of the people that just came out of college, this might be easy for them. It's kind of fresh in their memory. But maybe not, because that was some early stuff that you had done a couple of years before graduating. So go through, remember some of your basic formulas. You definitely want to know Ohm's law. But you've got KVL, KCL, you've got Ohm's voltage law, Ohm's power law, you've got Thevenin, you've got Norton voltage sources, you've got nodal analysis, mesh analysis, superposition. There's all these different theories that potentially could come your way. So make sure you have at least a basic understanding of those. Just really quick, go over them so you don't get caught with your pants down. Okay, so you prepared your resumes, you've got a notepad, you've got your pens and pencils and your calculator and your show and tell stuff. You're good to go, right? No, not exactly. One last thing. Remember, this is still a professional interview. They're going to ask tough questions, and you got to be prepared to answer those tough questions. One question that they're likely to ask, name something that you could improve on. And I think people are tempted to say this age-old answer of, well, I'm a bit of a perfectionist. Trust me, they've heard it before. They're not impressed. Your best bet, be honest. Chances are there's something you could improve on, and they'd be interested to hear it. And they're going to see whether or not you're going to give an honest answer or you're going to cop out. I'm not perfect either. I fully intend on going to this interview tomorrow and saying something along the lines of, well, I'm not very good at, formal FMEAs, that's failure mode effect analyses, DFMEAs. See, I can't even name all of them. There's several that I frankly could improve upon. From the technological standpoint, I think I'm in pretty good shape. But we all have things that we can improve on, and it's important to admit our faults, because once you've done that, you've opened up the door to improve on it. Another thing they're likely to ask is, name an experience that was uncomfortable, some kind of uncomfortable situation you were in. And that's a tough question. You really got to think about it. That's why you want to think about this before you're in the interview, so you have the answer ready to go. You don't want to sit there and fumble and say, let me think about that. I don't know. You don't want to be stammering. What you want to do is have your answer ready. So I think maybe it would help if I share an example that I plan to use if that scenario comes up, and maybe it'll get you thinking about some of your own experiences. Okay, so here it is. I was working for a company. It was a company that contracted for the auto industry. I work in Detroit, and this particular manufacturer I was working for designed and built test equipment for testing vehicles on the assembly line, because you don't want to get done with the vehicle and then find out, oops, we built that whole car and something doesn't work. Oh, now what do we do? Well, there's only like 20,000 parts. We'll figure it out. No, you want to be fairly certain that when that car's built, it's going to work. So this particular apparatus that I had designed and built was a window tester. What it would do is
you'd plug it into the door, and it had CAN bus signals and a power supply, and it would send a CAN bus message telling the window to roll up, because geez, every part of a car now has its own microprocessor, and that includes the door, believe it or not. The windows are smart because they have to sense things like, little Susie stuck her arm out the window. You don't want it to cut her arm off. You want it to stop and reverse itself and open up. So what we needed to do was to be able to roll up that window, sense the kind of current that it's drawing, to understand whether or not we're hitting Susie's arm or we're hitting a snag, because we're rolling them up for the very first time. We need to break those seals in. Well, we don't want the window to stop necessarily just because it hit a snag in the seal as it's breaking it in. You want it to push a little bit harder, but you want to be able to set that to a certain point. Well, what was happening is these windows were going up. Once we sent it to the plant and they were using it, they were going up, but sometimes they were stopping halfway, sometimes they'd stop a little bit further up. It was pretty random. It was really hard to tell. So the plant was in Louisville, Kentucky. I drove down from Detroit to Louisville on the weekend, and I had to wait for the shift to start the following day. And unfortunately, if you've ever been to an automotive plant or many different types of manufacturing plants, they don't let you stand there right on the assembly line. You've got to stand off to the side because you've got people working on the line. You've got forklifts and pacer trucks and all kinds of traffic moving all over the place that you don't want to be in the middle of for safety reasons and productivity reasons. So I had to kind of stand back for the 2 or 3 hours that the shift was happening and just watch and try to figure out what the heck was going on here, because I only got 20 minutes between shifts, or between breaks I should say, during the breaks to test this. So I can't actually test it in situ while they're operating. I have to just observe, and then once they're done with their work and they go on coffee break, go in there and try to figure out what's going on. Well, that's tough. It was really hard to try to figure this out. And to make matters worse, the customer is pressuring me. It's a high pressure situation. They got to get these windows going. Every single car they get out with the window not up is a defective unit. So there's a lot of pressure on us. The operator that was doing the particular job was brand new, so he didn't have much advice to help me because he's just learning the job himself. He was really struggling and falling behind. So that made it a little bit more complicated. So, we're both feeling the pressure. So my first thought is, well, they must have the current set point set way too low. It's sensing the current and it's shutting down on high current way too early. So let's jack that current setting up and see if that works. Like I said, unfortunately, I can't put a meter on it and then roll the window up and see what kind of current we draw, because I'm not allowed to test this thing while they're operating, and I'm not allowed to roll the window up on the car. So it's a really difficult situation to try and troubleshoot this. So that seemed like a fairly obvious thing to do. I knew we were well within our safety margin, so I upped the current. And I noticed that now the windows seem to go slightly further, but it really didn't solve the problem. So I decided at this point, it's now more than halfway through the day. It's taking a lot longer than I had hoped it would. And I took a step back and thought, let's take a systematic approach to this. I can only observe. I have plenty of time to observe vehicle after vehicle. So I got my laptop out and made a spreadsheet, and I started observing if there was any patterns. Here's the VIN number of the vehicle. Was it a front door? Was it a back door? What kind of vehicle was it on? How long did it travel before it stopped? And I sat there and monitored 200 or so cars over the course of the shift. And when I was done, I started binning the data, and I started noticing that there were some patterns. And in fact, one thing that stuck out was there's actually 2 pendants that they could plug into with 3 different connectors for the different types of vehicles they might encounter. There's a front door pendant and a rear door pendant. And I noticed that the failure occurred when the wrong pendant would be used, but here was the thing that was confusing. It worked with the wrong pendant, but then 2 doors later, it won't work. So it took a little bit of time to try to figure that out. But once the data was in the spreadsheet and you could see wrong pendant used, boom, boom, failure. And then some would be good, and then wrong pendant used, boom, boom, failure. And so it started coming clear in the data. So sometimes when you're in a tough situation like that, there's a lot of pressure. It pays to step back, think the problem through logically, and keep your cool. You have difficult situations where a customer might be putting pressure on you, but you can't let that upset your sensibilities. So I guess the moral of the story is, yes, it was a difficult situation, and it turned out that this happened because the customer in their specification, with which nobody else reviewed, just one person had written a specification that said we want a front door and a rear door, and then they train their operators, unbeknownst to us, to say, well, it doesn't matter which one you use. You can grab this one or this one. If it fits in the connector, that's fine. Well, that's not exactly the way it was designed. We designed it per the specification. So, of course, the customer was upset when you tell them that, hey, this is your problem here. It seems like it's a training issue. So I wrote up some training about how it should be done properly based on the current design, and made the suggestion that in the future, it'd be a good idea if we have a design review meeting. We all meet, we discuss the technical requirements, everybody has their input, we sign off on it, and that way when we have an end product, everybody's happy with it, everybody signed it, and everybody knows what they're getting. So that actually ended up changing the company procedure for both parties, and that kind of issue didn't crop up anymore. So I hope you found that interesting. Sorry I'm waving my arms around like wacky inflatable arm guy, but I tend to talk with my hands. So anyway, I hope that was helpful. I hope these are some good interview tips. By all means, if you have anything else or you disagree, please leave it in the comments. Any positive advice that you can give to new people starting out, or people just graduating that need to go on their first interviews, by all means, leave it. It's always great. I like to see the discussions and see people helping each other out. So anyway, I'll see you next time. Don't forget to like the video. If you haven't subscribed, go ahead and do so if you like what you saw. And follow me on Twitter at OhmsAtHome. See ya.